It's probably one of those demos that everybody does already, but even the simple demos are worth revisiting from time to time. Checking in with Kleeps before I did the diffusion demo this year reminded me that there have been a few updates, and certainly some people tend to overextend the applicability of Graham's law to this demonstration, so let's discuss diffusion. So the basic idea with this technique is that you have vapors of ammonia and hydrogen chloride that diffuse through a tube, and where they meet you end up with a white ring of ammonium chloride to show that the vapors have diffused through that gas. Now, some of the descriptions for this demonstration suggest using pretty long tubes, but actually I find something in this kind of length gives us a result in under a minute, and you can hold the class's attention for that period of time. The favorite thing that I picked up from revisiting the Kleeps technique was their suggestion of a way of actually inserting the chemicals whilst also stopping the tube at exactly the same time. And to do that, you're going to make yourself an adapted bung. So what you want to do is drill a hole inside the bung and then insert half a cotton bud and wrap a little bit of extra cotton wool around the end of it with an elastic band so that you can move each chemical to the tube and seal it all in one step. Work in a fume cupboard wearing splash-proof goggles, proper gloves, and fresh ammonia and hydrochloric acid. You absolutely want to be using stuff straight from your reagent bottle rather than using stuff that you've had out for a while for this demonstration to work at its best. Prepared up to 4 centimeter cubed of the liquids into sample vials, which are themselves in small beakers for preventing spillages, and later on for catching any drips from your tube. Keep these at least 1 meter apart before and during the demonstration. The tube can be supported with a clamp and stand, and when you're ready to start, all you'll need to do is place the bungs into each end at the same time. If you have a longer tube, a colleague might be able to help with this. The beakers that held the now largely empty sample vials can be left beneath to catch any drips. After a minute, a white circle of ammonium chloride forms, closer to the source of the hydrogen chloride than to the source of the ammonia vapors. As Graham's law doesn't apply to this situation, I tend to leave things here, but it is worth at least mentioning that the particles of hydrogen chloride are heavier than those of the ammonia. This can be further evidenced with the convection currents that establish on mixing. Although the presence of air molecules in the tube makes Graham's law inapplicable, it does set up beautiful convection currents as the NH3 vapors are less dense than air, while the HCl vapors and of course the fine particles of ammonium chloride, the product, are substantially more so. This swirling maelstrom slowly pushes towards the HCl side, leaving a trail of increasingly tilted ammonium chloride rings on the walls of the tube. Once you've finished the experiment, the bungs can be dumped into a beaker of water to dilute and neutralize remaining chemicals before washing down the sink. It's always worth revisiting those classic or easy demos that you've just always done this way, especially for updated health and safety guidance. I'd actually forgotten about the importance of using the freshest reagents possible. My technician reminded me this year, thanks Daniel. And that little extra tip about adding the cotton wool bung to the end of the tube at the same time is definitely something that I'll be taking forward from here on out. So if you don't already do that, give it a try.